I said I wanted to show you another example, and this one's going to involve some negatives. The last one we did, the first example, had all positive numbers, so that made things relatively not so bad. Okay, but let's look at another example. So let's look at this one right here. So I want to try to factor 20x squared minus 7x minus 6. I want to know what the factors of that are. I want to break it down further. Now, this one doesn't have any GCF in it, so if you try to find a GCF, there isn't one. So we go straight into our trinomial factoring. We see it has 3 terms, trinomial, so we're going to try our box method to do that. All right, so now this is the most fun part, is drawing the box. So let me draw the box. This box represents our problem. We know it's going to factor out into 2 binomials, so we divide our box in 2 sections each way. Okay, so remember the setup. So the first term, which is negative 20x squared, that will go in the upper left-hand corner. So 20x squared goes here. Okay, then the constant term, which is the third term if you have it in descending order. Now, be careful, there's a negative sign attached to that 6, so we got to carry that negative sign along with it. So the constant term, which is negative 6, goes in that lower right-hand box. Okay, so that's the setup. Now, in order to figure out how to split up the middle term, which is negative 7x, into these other 2 empty boxes, we got to do ourselves a diamond problem here on the side. Okay, so remember how to set up the diamond. You take, ignoring the x's, just the coefficients, first times the last. So 20 times negative 6. 20 times negative 6 is negative 120, and that goes on the top of the diamond. Okay, so negative 120 goes there. Okay, then we take the middle term, again, ignoring the x's, just the coefficient, which is negative 7. Don't forget to carry the negative sign along with it. Negative 7, and that goes on the bottom of our diamond. Okay, so here's our diamond problem. So we got negative 120 on the top, negative 7 on the bottom. So we're looking for 2 numbers that when you multiply them together gives you negative 120. So one thing we know right off the bat is that they have to be opposite signs. One has to be negative, one has to be positive in order for them to multiply together to give you negative 120. Then when you add them, you have to get negative 7. Okay, so that means that the larger one is the larger one in terms of size, magnitude, is the negative one. Okay, so again, I'm going to ask you to pause the video. Pause the video. If you don't know what the answer is right off the bat, pause the video. I want you to actually struggle and think about this one. This one has a little bit larger number set, negative 120, negative 7. So you might have to fiddle around. Don't be afraid to pull out a piece of scratch paper and just fiddle with some numbers. But I want you to pause the video and don't start it again until you know what the answer is. Okay, all right, so what you should have found, if you're honest and you haven't started it again until you know, what you should have found was negative 15 and positive 8. Negative 15 and positive 8. And that's because negative 15 times positive 8 is negative 120. Negative 15 plus positive 8 is negative 7. Okay, so there's our combination, negative 15, 8. And depending on the size of your coefficients, you might have to fiddle around with it a while. It may not be immediately obvious, so you have to do some trial and error. But once you got over that hurdle, once you figure out those 2 numbers from the diamond problem, then you are kind of on the home stretch. All you got to do is just the mechanics of finishing it off. So negative 15 and 8, figuring that out, that tells us how to split up the middle term so that we fill in these other 2 boxes correctly. So one of the boxes will have a negative 15x, and the other will have a positive 8x. When we put it back in, we put back in the variable with it. So now since those 2 numbers tell us the middle term, and the middle term has a variable of x, that's what we put in when we fill in those 2 boxes. Okay, and again, it doesn't matter which one you put where. Either one will go in either box. So I'm going to put negative 15x here and positive 8x in this box. Okay, so now we finish it off. So what we do first is we GCF across the top row. So GCF across the top from right to left, we put the GCF here on the left. GCF across the bottom row, right to left, put the GCF here on the left. Okay, so the top row, negative 15x and 20x squared. So 15 and 20. Okay, GCF of 15 and 20 is going to be 5. Variables, x squared and x. GCF of x squared and x is just x. Okay, now we go to the bottom row. 8x and 6. Okay, 8x and 6. So 8 and 6. GCF of 8 and 6 is going to be 2. X and no x with the 6. So the GCF of the variables is nothing. They don't have any x's in common, so it's just 2 as the GCF overall. Okay, now we go up the columns. So let's do the first column, bottom to top. 8x and 20x squared. So 8 and 20, GCF of 8 and 20 is 4. X squared and x, GCF of x squared and x is just x. Okay, and then we do the second column. So 6 and 15, GCF of 6 and 15 is 3. Variables, x in the top and no x is on the bottom, so they don't have any x's in common, so it's just 3, period. Okay, now you see there's some negative signs involved, so this is where the rule for negatives comes in, and this is where it's going to be important that you got to go from, on the rows, you got to go from right to left and write the GCF on the left. And in the columns, you got to go from bottom to top and write the GCF on the top. Okay, that's because the rule for negatives is if the box closest to the edge, so if the box closest to the edge, like this one right here, has a negative in it, has a negative term in it, then the GCF on the outside is going to be negative. Okay, so if the box next to the edge, closest to the edge where you took out the GCF is negative, like right here, this box in the upper right-hand corner, if it has a negative term, then the GCF should be negative. Okay, so actually this 3 should actually be a negative 3. Okay, so again, the rule for negatives is if the GCF, or if the term, in the box closest to the edge has a negative term in it, then the GCF is negative. If the box closest to the edge has a positive term in it, then the GCF is positive. Okay, so like these two here are positive on the edge, so that's why the GCF is positive. Going up, this one here is positive, so that's why the GCF is positive. But this one here had a negative in the box closest to the edge, and so that's why I have to make this GCF a negative. Okay, now let's just double check just to make sure that everything worked out consistently. So let's just check the inside of the boxes. So if I multiply back together, 5x times 4x is 20x squared. That works. 5x times negative 3 is negative 15x. That works. 2 times 4x is 8x. That works. And then 2 times negative 3 is negative 6. That works. Okay, so everything works out. So we have here our factorization. Again, here it is. So our original problem, 20x squared minus 7x minus 6, breaks apart as 4x minus 3 and 5x plus 2. You get the factors from the edges here. And again, it doesn't matter what order you list the factors in. Whether you list 4x minus 3 second or first, it's both the same. Okay, so these are our factors of this trinomial. Okay, all right, so now you know about factoring trinomials. But the bad news, or the good news if you like challenges, is that's not the end of factoring by any means. This only works, remember this is talking about trinomials, so this only works when your problem has 3 terms, a trinomial. What if it has a different number of terms? What if it has 2 terms or 4 terms or a different number of terms? Then we have to learn a few other techniques for factoring those types of scenarios. Okay, so this will be the end of factoring trinomials, but not the end of factoring altogether. So next, let's take a look at binomials, 2 terms. So what if your problem had only 2 terms? How would you factor that? We're going to see that that's actually going to be a special case of 3 terms. So since we already know trinomials, that's going to make the 2 terms a little bit easier. So let's go on and take a look at that next.